Hello everyone, very good evening to all the PU2 champions here out there who are preparing for their PU2 first unit test on chemistry. So students, just let me know if I am audible, if everything is clear, and if I am audible clearly, please put a thumbs up. And I know many of you have been waiting for this session, and we are going to discuss all the important questions for tomorrow's, those who are having exam tomorrow or in another date. This video will be helpful for all those students, and we have picked up almost 60 questions, and we have also I'll also be telling you the most important topics, okay, that has to be like you must revise before going to the exam. Okay, and one more important thing is we'll be discussing the MCQs, okay, so that you don't miss any that single mark in your exam, okay, and the last minute revision, what all topics you should be doing, that also I'll be telling you. Okay, so with this, and now let's quickly start from the first question itself. So we have what chapters? So I have got this three chapters, that is solutions, D and F block, and haloalkanes and haloarenes. Solutions from physical chemistry, D and F block from inorganic chemistry, and haloalkanes and haloarenes from organic chemistry, right? So now first we'll go to solutions chapter, okay, and I have brought 20 MCQs. So what you have to do is put down your answers in the comment section quickly, and just I'll be discussing the questions and some numerical questions also I have. So you should be sitting with your calculator, pen, pencil, paper, everything, so that you can solve the questions with me. Okay, so now let's get started. Just let me check with all the students if everything is fine here. Okay, first question is here: which of the following is dependent on temperature? This is very common question and have been asked multiple times in different exams, that whether it is molarity, mole fraction, weight percentage, or molality. Yes, please answer this question. So let me see, we have 31 students. So first let me greet all of you. I'm very sorry I missed so many students. So Sanjeev, hello, good evening. Mohammed, very good evening. Shravani, very good evening dear. And yes, ARN, Saraswati, Tracer, so a very good evening to all of you. Okay, so I'll be going little bit fast here, so because this is very simple question. And yes, we have molarity as the correct answer. Here I can see Tracer Money Hunt has given the correct option. Okay, hi Kirti, hi Hacker, very good. So students, you can just put down options quickly, don't have to write the full answer, save your time, but not in the exam. Now you can just put down the option. Now what is the reason here? Let's quickly discuss. Molarity is equal to number of moles by volume, right? And when temperature increases, volume will also increase. If volume will increase, molarity will decrease, right? This is expansion. When the temperature increases, the volume of the solution will expand, right? Very simple. Yes, so students, if you get any doubt in any question, just stop me there. I'll be explaining the concept. Otherwise, we'll be moving to the questions quickly. Okay, next, are you all ready for the second question? Yes. So here I have, which is the following compounds that can be used as an antifreeze in automobile radiators? So if you read the solutions chapter in the applications part, and somewhere this part is mentioned, so which can be used as an antifreeze. So what is the answer for here? Bharat, hi dear, hello. ARN is giving D answer. No, antifreeze is not ethyl alcohol. You are very close, but it is not ethyl alcohol. Anyone else? D, I am getting so many answers. See, students, it is actually ethylene glycol. Okay, we call it ethylene, so this is glycol. Okay, it is not ethyl alcohol. The option you might get confused. It is glycol actually. Okay, glycol is the compound which can be used as an antifreeze. Yes, those who are saying C, that is correct. Saraswati, yes. RP, Harshi, so students, please don't get confused. It is glycol, okay, not ethyl alcohol. Glycol structure is like this. Okay, 2C and then 2OH group. Okay, moving to the next question. The dissolution of gas in a liquid is governed by, very easy question, but yes, very important. Raoult's law, Henry's law, Dalton's law of pressure, and Van't Hoff factor. Can anyone tell me what is the correct answer here? Please put down the question number and the answer so that I can know which one you are answering. Yes, those who are saying B, it is absolutely correct. Wonderful, all of you. So B, Henry's law is the correct answer, and we know that Henry's law states as the pressure increases, the solubility increases, right? Here what all questions can be asked? Henry's law, you should be revising the definition, the formula, okay, and what is the significance of Henry's constant and applications of Henry's law. Okay, quickly you should be revising these 4 points about Henry's law. Okay, moving to the next question number 4, the mole fraction. Yes, very tricky question. Please take some time and answer. The mole fraction of the solute in 1 molar aqueous solution is. The question here is the mole fraction of the solute in 1 molar aqueous solution is 0.009, 0.018, 0.027, 0.036. You need calculator for this, so please use the calculator. I'll give you 1 minute time, then you can solve it. Yes, I can already getting the correct answer for this question. That is really wonderful. So yes, congratulations to Treasure, Money Hunt, and we have Harshit here, Aditi, Kirti, Hacker. All of you have given really correct answer. So see here, what is actually this question? The mole fraction of the solute in 1 molar aqueous solution. So I have number of moles, how much? Number of moles is 1. 1 molar means number of moles is 1. When I say 1 molar, what does that mean? It means 1 mole in 1 kg of solvent, right? So I can say that number of moles of solute is 1 mole. What is the mass of the solvent? Mass of the solvent is 1 kg. Or 1000 grams. This is the mass of the solvent per kg, right? And it is given aqueous solution, that means solvent is water. So what is the number of moles of solvent? Given mass by molar mass, given mass is 1000, molar mass is 18, you will get this one as 55.5 something. Now what you have to calculate? The mole fraction. So what is the mole fraction of the solute? Solute mole fraction is number of moles of solute, right, divided by number of moles of solute plus number of moles of solvent. Okay, so here I have number of moles of solute is 1, number of moles of solute is again 1, and number of moles of solvent is 55.5. So that you will get 1 by 56.5, and if I solve this, you will get 0.018. Okay, yes, Sanjeev, please put down your doubt. If you have any doubt, just put down in the comment section. I'll be taking it. Okay, yes, we will, yes. So I hope this is clear. Everybody is clear with this question. Please say if it is clear, all of you. Please put a thumbs up or tell me that it is clear. Next we'll go to the second, fifth question. Is it clear to all students? If it is clear, please put quickly a thumbs up in the comment section and let me know that this question is clear to all of you. Yes, Mohammed has said yes, Kirti has said yes. Okay. Sanjeev, it is mole fraction, beta. It is not mic fraction. Have I written anywhere like that? This is mole fraction. Mole fraction means number of moles of the solute divided by the total number of moles. Okay, that is called as mole fraction, not mic fraction. Okay. Yes, definitely I'll be providing the PDF of the important questions also. Now let's see question number 5. Which one of the following is not an example of a solution? Very tricky question. Now see, whenever I talk about solution, you should understand it as a homogeneous solution. Okay, the question is asking which of the following is not a homogeneous solution. So can we answer this one? Yes. Which is the example of a homogeneous, not an example of a homogeneous solution? Air, yes, air is definitely a mixture or a homogeneous solution. Brass is a homogeneous solution. These all are alloys. So these are all homogeneous solution. Benzene in water is an immiscible liquid. Okay, it is an immiscible liquid. So if it is an immiscible, it is not homogeneous, it is heterogeneous, right? So that is why the correct answer here will be option number D. Okay, so D is the correct answer. Now let's move to the next question number 6. If 1 mole of a substance is present in 1 kg of solvent, then it shows molar concentration, it shows molar concentration, it shows normality, it shows strength. Yes, can we answer this question quickly, students? All the bacha party, please answer here quickly. Yes, 6 I have got answer B. Yes, very good, very good. Very good, Harshit and Varsha. So many students are there now. Manjunath, hello, Kirti. So Neon, Kirti, everyone, hi, hello. I have missed some of your names. Sorry for that. But yes, molal concentration, right? 1 mole in 1 kg, that is molal, and 1 mole in 1 liter, that is molarity. Okay. Next, question number 7. So this is a statement based question, very, very important question. See, statement number 1 is, on adding NaCl to water, its vapor pressure increases. The second statement is, addition of a non-volatile solute increases the vapor pressure. So if both the statements are correct, statement 1 is correct, statement 2 is wrong. Statement 1 is correct and statement 2 is incorrect. Statement 1 is incorrect and statement 2 is correct. What will be the answer for this one? Yes, I have get so many answers. Sangeeta, Harshit, yes, everybody is correct here. Both the statements are wrong. So whenever we add a solute, the vapor pressure will decrease. Okay, whenever we add a solute, the vapor pressure will decrease. Okay, non-volatile solute, if you add, the vapor pressure will decrease. What is the reason? Let us quickly revise that. So if you have a solution here, these are all vapor particles, they will evaporate, right? And here they will create vapor pressure. Now when you add solute, what will happen? Some of the surface molecules will be occupied by the vapors. Sorry, by the solute particles, right? Now earlier, suppose 10 molecules were evaporating, now 6 molecules will evaporate. Why? Because some of the particles are now, the spaces are overlapped or covered by the solute particles. Okay, so that is why we have this answer. Next, yes, this is also a very important question. PA and PB are the vapor pressures of the pure liquid components A and B, respectively, of an ideal binary solution. If XA represents the mole fraction of component A, the total pressure of the solution will be. Okay, so yes, can we answer this one? Okay, so I want everyone to answer with question number. Okay, students, please answer with question number. Yes, 8B, I am getting B as the answer. Okay, so let's see here. What is P total? P total is PAXA, right, plus PBXB. Now see, actually in the book it is written P0AXA plus P0BXB, but in the question they are saying that PA and PB are the vapor pressure of the pure solvent. So I will take PA in place of P0A. Now what I can do? PA plus, I can write this one as XA plus PB into 1 minus XA, right? This XB can be represented as 1 minus XA because XA plus XB equal to 1. Now what I can write here? PAXA plus PB minus PBXA, right? So what will happen? I can take a common here XA. So PB I'll take here. PB plus XA is taken common. I have PA minus PB. Okay, so I can find which option here? Yes, Sangeeta and Vidyanand have given correct answer, that is option number D here. Okay, 9th question, the vapor pressure of two liquids P and Q are 80 and 60 torr respectively. The total vapor pressure of the solution obtained by mixing 3 moles of P and 2 moles of Q would be. Please take your time, solve it. Yes, Varsha, it is D. So please take your time and then solve and then answer. Okay, don't be in hurry, you will get it wrong. Please take your time and then solve and tell me the answer. I'll give you 1 minute time for this question. Please solve it. Okay. Yes. Okay. I am waiting for your answer quickly. We have to calculate the total pressure. 9A. Ashia, very good. Absolutely correct. 9A is the correct answer. See, you have P, okay, and Q. What is the vapor pressure of pure P? 80, and for this one it is 60. Okay, next, what is the moles of P? Number of moles of P is 3 and number of moles of Q is 2, right? Now what I can do? Mole fraction of P. So number of moles of P divided by the total number of moles, 3 by 2, 3 plus 2 is 5, and number of moles of Q will be number of moles of Q divided by total number of moles. Now what is the formula for P total? P total is equal to P naught A XA plus P naught B XB. Now what is P naught A value here? 80. XA is 3 by 5, okay, plus P naught B is 60 and mole fraction of Q is 2 by 5, okay. So I can just cancel this one, 16, and here you have 12. So if I add these two, I'll get 72, which is option number A. Yes, all of you are absolutely correct. Yes, PDF is available, Mood, you will definitely get it, okay. The mixture which shows positive deviation from Raoult's law, very good question, positive deviation. Ethanol plus acetone, benzene plus toluene, acetone plus chloroform, chloroethane plus bromoethane. Positive deviation. Positive deviation, how we will get? Positive deviation. I am getting answers. 10 is A, yes, absolutely correct. Positive deviation means weak interactions, okay, weak interactions. Now ethanol molecule have very strong hydrogen bonding, right? They are very strongly bonded with hydrogen bond, but when you add acetone to that, the hydrogen bond is disrupted. So that is why it shows positive deviation, okay. 10A. Next, 11th question, the mixture that forms maximum boiling azeotrope. Heptane plus octane, water plus nitric acid, ethanol plus water, acetone plus carbon disulfide. Maximum boiling azeotrope. Maximum boiling azeotrope. So that means it should have what? Positive deviation or negative deviation? It should have negative deviation. Okay, it should have negative deviation. The bond, the interaction should be very strong, that we need a very high temperature to boil them, and that is why we get maximum boiling azeotrope here, right? So the correct answer will be for 11th, it is no dear, ethanol and water does not form an isotope, okay, at this one. So it is water plus nitric acid, okay, water plus nitric acid. Ethanol plus water will show positive deviation, and that is why they have a minimum boiling azeotrope. Okay, question is asking maximum boiling azeotrope, okay. So don't get confused here, examples are very important, so please write down all the examples. What all examples you should remember? Ideal solution, non-ideal solution. Next, positive deviation, negative deviation. Next, maximum boiling azeotrope and minimum boiling azeotrope. All the examples should be written and remembered properly before the exam, okay. Next, we will have question number 12 here. Which of the following statements is correct regarding a solution of two components A and B exhibiting positive deviation from ideal behavior? Okay, so what is correct when two solutions are having positive deviation? Intermolecular attractive forces between AA and BB are stronger than those between AB. Is it a correct statement? V mix is not equal to 0, H mix is not equal to 0. Intermolecular attraction forces between AA and BB are equal to those between A and B. You have to see for, that is for positive deviation, right? Yes, in positive deviation, what happens? You have to tell which is correct statement. Okay, just a minute. Positive from ideal behavior, yes. What can be the answer here? I think the options are slightly incorrect here. Intermolecular attractive forces between, yeah, so this is the correct statement, yes. So in positive deviation, what happens? AA interactions and BB interactions are stronger than AB interactions, right? So intermolecular attractive forces between AA and BB are stronger than AB. So that is your positive deviation, option number A here. Yes, absolutely correct. Those who are saying D. So Ramesh K, you are saying D. See, this condition is required for ideal solutions. Okay, ideal solutions, we should have this one. Next, we'll go to 13th question. Which of the following statements about the composition of the vapor? We are talking about the composition of the vapor. Okay, we are talking about the composition here, vapor. Of an over an ideal 1:1 molar mixture of benzene and toluene is correct. Means here you have mixture of toluene and benzene. Okay, the ratio of this is to 1:1, and then it is given that assume that the temperature is constant. The vapor pressure of benzene is 12.8 kilopascal. Okay, and that of toluene is 3.85 kilopascal. Okay, so the question is asked, in the vapor phase, whose composition will be more? whether we see in the solution phase both are 1 mole, right? Here also this is 1, the ratio is 1:1 means we have equal number of moles. But the question here is when they are evaporating in the vapor phase, which will have more like I can say which will have more concentration, whether it is benzene or toluene. I can find the answer here, that is okay, so I can see 12th nobody has answered yet, 13th C is there. Okay, so 13C, the vapor pressure will contain a higher percentage of benzene. Yes, definitely. Why? So you can see that benzene vapor pressure is high. That means what? It will evaporate more. Okay, it will evaporate more. So that means more benzene will be collected here as compared to toluene. So that is why in the vapor phase benzene composition will be more. Option number C. Okay. Mood after the class, after the live session you will get the PDF, not now. After the class is over, then only you will get the PDF session, the PDF of this session. Okay. Okay, next we have 14th question, that is a solution containing components A and B follows Raoult's law. Okay, so here before that I want to thank Ashia first of all. Hi guys, follow this channel. I have today chemistry exam and I will get 32 out of 35. So Ashia, that is really good and I'm very proud of you that this channel could help you in that. So thank you so much and all the best for your next exams. Okay. Yes, so we have here solution containing components A and B follows Raoult's law. So what does that mean if they follow Raoult's law? AB interaction force is greater than AA and BB. AB attraction force is less than AA and BB. AB interaction force remains same as AA and BB. Volume of the solution is different. So what will be the correct answer? 14th C is the correct answer, absolutely. Why? Because in ideal solution that is the condition. The interactions between AA and BB is equal to AB interactions. Okay. Now we will have next question number 15. All form ideal solutions except. All will form ideal solutions except. What will be the answer for here? Which will not be having an ideal solution? Yes, we have here benzene and toluene. We have here ethane and iodoethane. We have here chlorobenzene and bromobenzene, iodoethane, and then you have ethanol. Which one will have a, which will not form an ideal solution? Not form. Neon, it is not form. A will definitely form ideal solution. Okay, here we will not have ideal solutions. They will have different types of interactions. So there is no ideal solution formed in case of yes. So it is option number D here. So Dhanva, we will try to finish this question, this session by 8:30. Okay, by 8:30 we will try to complete it. So next question, an ideal solution is formed when its components, okay, when do you get an ideal solution? Have no volume change on mixing, have no enthalpy change on mixing, have both the above characteristics, have high solubility. So what is the condition that will give us, what condition will give us that we will get an ideal solution? Yes, neon is correct here, C. Okay, so you should have delta V mix. Delta V mix should be equal to 0 and delta H mix should be equal to 0. Okay, that is the condition. Clear? Yes, 16C. Next question, if molality of the dilute solution is doubled. Very good question, I'll say, important. Okay, if the molality of the dilute solution is doubled, the value of molar depression constant Kf will be. So you have this formula, delta Tf is equal to Kf into M. Right? So how can I establish a relation between this one? Molality is equal to delta Tf is equal to Kf divided by Kf. Now the question is saying that if the molality of the dilute solution is doubled, if molality is doubled, then what will happen to Kf? Let me see who answers this question. Rohit, yes, definitely you can get 30 above if you follow all the important videos that I have made. Okay, 17th A, students are 17A. Okay, the answer is option number C. I have done this to confuse you. Okay, so remember, molar depression constant, it is a constant value. It doesn't depend on any other factor except the temperature. So whether your molarity is doubled, tripled, halved, it doesn't affect the Kf and Kb value at all. So the correct answer here will be remains unchanged. Okay, no, those who are saying A, please get it correct. I have knowingly, intentionally told you in this way so that you will think in this way, and here's what you should not do the mistake. Okay, so this is a constant and it remains unchanged. Clear? Okay, very good. Next, two more questions of this particular chapter. During osmosis, the flow of water through a semi-permeable membrane is from solution having lower concentration only, from solution having higher concentration only, from both the sides of semi-permeable membrane, from both the sides of the semi-permeable membrane, with equal flow of rates, with unequal flow of rates. I'll say this question is confusing. Okay, so please answer properly. From solution of lower concentration, the flow of water through a semi-permeable membrane is from a solution having lower concentration or a higher concentration. Yes. Okay. Yes, those were A saying A, that is absolutely correct here, from solution of lower concentration. Okay, so when you lower concentration means you have more water there, so from that side to the higher concentration side, the water or the solvent will move through the semi-permeable membrane. Okay, next 19th one here. No, those were saying B, it is wrong. Mohammed, B is wrong dear. See, from solution having higher concentration. Now if you have like this, okay, this side I have low concentration and this side I have higher concentration. Whenever we talk concentration, it is about the solute concentration. Okay, less concentration, more concentration, so solvent will move from this side. Lower concentration of solute to higher concentration of solute. Okay, next we have here, yes Tarun, definitely I'll do that. Tarun will, now I'll be doing that. Okay, definitely Tarun. Okay. Pure water can be obtained from sea water by, what is the process here? Can you answer here? Centrifugation, reverse osmosis, plasmolysis, sedimentation. Quick answer from all of you, please. Quick. Very easy question, this one. Yes, Neon, Mohammed, all of you are giving correct answer. Show a big shout out for all of you. Yes, Bharat is also saying C, Ashwini is also saying C. So all of you are absolutely correct here. Let's move to the 20th question here. From the colligative properties of solutions, which one is the best method for the determination of molecular weight of proteins and polymers? Yes, Tarun and yes, all Ashwini, all of you have given correct answer. Then we have osmotic pressure, lowering in vapor pressure, lowering in freezing point and elevation in boiling point. Mohammed, absolutely correct and the fastest one to answer here. So it is osmotic pressure, which is option number A. Okay, osmotic pressure is used for calculating the molecular masses of bigger molecules, right? So that is why it is option number A. Now here a 3 marker or 2 marker question can be asked, that is why osmotic pressure only can be used to measure the molecular masses of macromolecules. So here there are 2 reasons. The first one is it uses molarity. Okay, second one can be calculated at room temperature. Okay, so please remember these 2 important points. Okay, 20A. Now we will do some numerical questions. So please quickly sit with your calculator. Okay, read the question and solve it. I'll be just telling you how to solve it. Okay, so first question here is 22 gram of benzene is dissolved in 122 gram of carbon tetrachloride. Determine the mass percentage of carbon tetrachloride and benzene. Very simple question. Please try this and answer me. Only 5 numericals I have taken. Okay, only 5 numericals are there. So yes, can we answer this quickly? Okay, so let's see. So we have 22 gram of benzene and 122 gram of carbon tetrachloride. So what is the, I can say, total mass? Total mass is 122 plus 22, that is equal to 144. Okay, so what is the percentage of benzene? Benzene percentage will be 22 by 144 into 100. Okay, and what is the percentage of carbon tetrachloride CCl4? That is 122 by 144 into just a minute, yes, into 100. Okay, so that will be the answer if you solve this. we will get 1% will be around 15, that is of benzene will be around 15, and for chloroform it will be around 85%. Yes, neon is absolutely correct here. Let's move to the next question. The vapor pressure of a pure liquid A is 40 mmHg at 310 Kelvin. The vapor pressure of this liquid in solution with liquid B is 32 mmHg. Calculate the mole fraction of A in the solution if the mixture obeys Raoult's law. Very easy plus confusing questions. Try this. Yes, try this question, students. Please try this question. Only 5 numericals I have given you. This is the second one. So the question here saying is that for pure liquid A, that means P naught A is how much? 40. Okay. Next we have the vapor pressure of this liquid in the solution with liquid B is 32 mmHg. Means whenever it is present in the solution, its pressure is 32. Means the P value of A is 32 mmHg. Now what does Raoult's law say us? That PA is equal to P naught A XA. Okay, what I have to calculate? The mole fraction of A. So mole fraction of A will be PA divided by P naught A, which is equal to 32 by 40. Right? So I can cancel 4 8s are 30, 4 10s are, so I'll get 0.8. Right? Anybody has got the answer here? I can't find anyone answering. Yes. So students, please see this and just let me know if this is clear to all of you. If this is clear to all of you, do let me know if this is clear, then we will go to the next question. Okay, I'll slow down a bit here. So if this is clear to all of you, just put a thumbs up quickly that it is clear for all of you, and then we will move to the next question. Okay, so I can find Neon has given yes ma'am. Others 17 students are almost live here, so please do let me know if this is clear to all of you. Okay. Yes, everyone, please see this. Okay, clear. Moving to the third question. Okay, next please try this question. It is a PYQ of March 2023 question. So 450 centimeter cube of an aqueous solution of a protein contains 1 gram of protein. Okay, the osmotic pressure of such a solution is found to be 3.1 into 10 to the power of minus 4 bar. Calculate the molar mass of the protein. Okay, so osmotic pressure question. Please, I'll give you 1 minute. Try this. Try this. Okay, Mohammed. Okay, Ashwini. It is clear to all of you. Try this question. Very simple and direct osmotic pressure formula based question. All of you can do this. Please try it and let me know in the comment section the answers. Okay. Yes. Okay. Mood. Tomorrow is live class timing. So Mood, just check the community post. We will be posting it. Okay. And I think tomorrow we have again bio live, I think. Okay, but I'm not very sure. So we will just check. You can check in the community post. We have already given all the schedule, or else tomorrow morning also we will be posting tomorrow's schedule in the comment in the community post. You can check there. Okay. Now please answer this question. Those who have already completed, dear children. Yes. I am not getting any answer in this question. Why, dear? This is very simple and direct question. Please, no need to write down everything. Just try to solve quickly and tell me the answer so that I know that you remember the formula and you know how to apply it. Yes, 23.38. Hi Noor Jahan, a very good evening. So hacker, no need to delete your answer beta. If it is wrong also it is fine. But let's see now. Okay. So what is the formula for osmotic pressure? Pi is equal to C into R into T. C is what? Molarity. How can I write molarity? Given mass by molar mass, right, into 1000 by volume of the solution in ml, right? This is C value. Then I have R into T and the pi value is already there. So let's substitute everything. Okay, I'll substitute here. What is the pi value? The osmotic pressure given to me is, so first let me write down what all values are given to me. 3.14 into 10 to the power of minus 4 bar. 3.14 is not there, 3.1. Next, 450 centimeter cube. So what is the volume here? 450 centimeter cube is 450 ml because 1 centimeter cube is equal to 1 ml. Next we have protein contains 1 gram of protein. So what is the mass of the solute? 1 gram. Okay. The osmotic pressure is there. R value is given to me that is 0.083. While I'm doing this, you can solve and give me the answer. Many are telling 18.444, 54. Okay, let's check. Okay, let's check. All of you have given the answer. Let's check the correct answer. Who gets the correct answer? Let's see. Okay, so I will now substitute. Pi value is how much? 3.1 into 10 to the power of minus 4. Then we have CWB is 1. MB I have to calculate into 1000 by 450. Okay, then R value is 0.083 and T value is how much? 310 Kelvin. Okay, so now I want this MB value, so I'll keep this one on one side and everything else I'll take to other side. So 1000 into 0.083 into 310 divided by 450 into 3.1 into 10 to the power of minus 4. So if you solve this, just put down it in the calculator. Okay, you can solve this, you will get 18.4444 gram per mole. There is not point, hacker, please check your question. I think there will be no point here. Please check once. Okay, check the calculation and tell me if you are getting a point here. Let me just see. Let me also calculate once. So I have 1000 into 0.083 into 310, then I have divided by 450, then I have divided by 3.1. Yeah, I'll get, after you will get 3.1, sorry, 18.4 you will get. Okay, but you have into 10 to the power of 4, this minus 4 will go up, right? So you have 444 like this, so you will get 184444 grams per mole. Okay, so point will not come. Those who are getting point, that is wrong. Please correct yourself. Yes, Neon, you will have calculative questions. Listen, Neon, you will have calculative questions, but you don't have to worry. You have the calculator in the exam, right? So you don't have to worry. And from the solutions chapter, these type of questions will be asked. Okay. Thank you, Vidyanand. Thank you so much. Okay. Let's go to the next question. Is it clear to everyone? See, this minus 4, right? It will go up and it will become 10 to the power of 4. And if I solve this match, this 1000, this one, and this one, I will get 18.444. And if you multiply with 10 to the power 4, you will get this answer. Okay, is it clear? Okay, everyone, let's move to question number 4. This is the second last numerical. After this, I have only one numerical. Okay, so 1 gram of a non-electrolyte solute is dissolved in 50 gram of benzene. Lowered the freezing point of benzene by 0.4 Kelvin. The freezing point depression constant of benzene is 5.12 Kelvin kilogram mole inverse. The molar mass of the solute is. So let's quickly find out this answer. Yes, this is from freezing point depression. So delta TF is equal to KF into M. So please, that formula we have to use and try to solve. I'll give you. Question is wrong. Nikhil, which question you are talking about? Please let me know, Nikhil, which question you are talking about. Okay. 5.12 should be given as 5. Dear C, this value, okay, you can now, whatever is given, 5.12 and 5.18 will not make much difference in your calculation. So with this, whatever given in the question, you calculate and tell me what will be the answer. Okay, Nikhil, I will check this definitely, but now with this, you can just solve and tell me the answer. Clear? Yes, students. Now please solve it quickly. 256. Vidyanand has given me the fastest answer. Now let me discuss the answer quickly. 1 gram of a non-electrolyte solute, right? So WB is 1 gram. Then dissolved in 50 gram of benzene. So what is the mass of the solvent? 50 gram. Always remember, B is for solute, A is for solvent. Next we have the freezing point is lowered by 0.4 Kelvin. So delta TF is equal to 0.4 Kelvin. Next you have the KF value. KF value is given to me as 5.12. Okay, so what is the formula? Delta TF is equal to KF into M. Now if I want to expand it, what is the molality formula? Given mass of the solute by molar mass of the solute into 1000 by mass of the solvent, right? Just now let us substitute everything, right? So what I will substitute, what I will get after substituting. So delta TF is 0.4. Okay, Kf value is 5.12. Then I have Wb is 1 gram, Mb is I have to calculate, okay. Then I have 1000 and Ma is 50, sorry, Wa is 50. So now let's just solve it. So Mb will be equal to 5.12 into 1000, right, divided by 0.4 into 50. Okay, so you can just solve this, we'll get 20 here, then you can cancel this one, and I think all of you will get 256 gram per mole. Okay, all of you are absolutely correct here. Very good everyone. We have Neon here, Hacker here, Mood here, Noor Jahan and Vidyanand. Okay, all of you have answered. Now let's move to the fifth question, the last numerical question here. On dissolving 3.46 gram of a non-volatile solute in 100 gram of water, the boiling point of the solution has raised to that of the pure water by 0.12 Kelvin. Calculate the molar mass of the non-volatile solute given the Kb of water is 0.51 Kelvin kilogram mole inverse. Yes, Ramesh, you can, okay, Ramesh has also given the correct answer here. Yes, all of you please do the next question. This is very simple. This is the last numerical. After that, we'll again come back to MCQs. That we'll solve it and then we'll end the session. So please just do this quickly and tell me what you will get the answer for this numerical. Okay. Yes. I hope all of you are solving. Let me just write down the data here. I have 3.46 gram of non-volatile solute. So what is the mass of the solute? 3.46 gram. Let me see whether I am solving faster or you are solving faster. Okay. Dissolved in 100 gram of water. So Wa is 100 gram of water. The boiling point of the solution was raised to that of the pure water by 0.12 Kelvin. So delta Tb is equal to 0.12 Kelvin. Calculate the molar mass of the non-volatile solute, and here we have Kb equal to 0.51 Kelvin kilogram mole inverse. Okay, again what we have to calculate? The same molar mass is what you have to calculate. I have got the answer from Vidyanand and Neon. So let's see. So I have this formula, delta Tb is equal to Kb into M. Okay, so I will expand and write down this one. That is Wb by Mb into 1000 by Wa. Okay, so what is delta Tb here? 0.12 and Kb value is 0.51, Wb value is 3.46, Mb value is how much? That is what I have to calculate, into 1000 by Wa is 100. Okay, so now we can just solve this to calculate Mb value. 0.51 into 3.46 into 1000, right, divided by 100, and then you have 0.12. Now if you solve this, let me see how much you are getting. Yes, 147.05 is the correct answer. All of you have got the correct answer here. Mood, dear, as I told you, the PDF of this session you will get once the class is over. Okay, so please just check that after the class is over in the WhatsApp channel it will be uploaded. Okay. Neon, from Vanter factor directly numerical questions will not be asked. In the MCQ some questions can be asked whose boiling point is higher, whose boiling point is less, but generally in your PU2 exams Vanter questions are less. Okay. So now I'll just tell you what all things you should quickly revise from this chapter. So students, take a screenshot of this one quickly. So please, once you go tomorrow before the exam, revise Henry's law, Raoult's law, and difference between these three: ideal solution, non-ideal solution, positive and negative deviation, maximum and minimum boiling azeotrope, and the colligative properties, all the four colligative properties and their formulas. This much you should revise and go for the exam. Okay. Mood, you can join the WhatsApp channel. The link will be there in the description section of this video. Okay, please join the WhatsApp channel. So all of you have taken a screenshot here. If you have not, please pause and take the screenshot. Now we will move to the second chapter, that is D and F block elements. Okay, so now let's do the first question of DNF block. According to the IUPAC, transition metals are defined as, very important question. What do you mean by transition metals? So transition metals are the metals which have incomplete d subshell either in the neutral atom or in the ions. Second, metal atoms which have complete d shell in the neutral atoms only. Metals which with chemical properties were transition between those of S and P block elements. Metals with chemical properties were transitional between those P and F block elements. Everybody should be able to answer this one. Yes, definitely it is option number A. So transition metals are those elements which have incomplete d orbitals either in the ground state or in the excited state, right? Let's move to the second question here. Very good, very good. A is the correct answer. A is the correct answer here. Next, the D block element not having general electronic configuration of N-1D, 110, NS12. There is one element which does not follow this this general electronic configuration, but it is a D block element. Can we guess that answer? Vidyanand, yes, I will go to that once I after this chapter I have haloalkanes and haloarenes, so I will come sequentially, beta. It's not like I'll jump there, I'll come sequentially. Okay, Ashwini is saying zinc, chromium. No, the answer is wrong. No, neon, zinc, cadmium and mercury are not the transition elements in their excited state also. Let me explain. See, zinc electronic configuration is 3d10 4s2, right? What is your excited state? It is Zn2 plus, or the ionic state is Zn2 plus. Here also it is having 3d10 configuration. So both in the ground state and in the excited state it has completely filled d orbitals, right? So that is why it is not having incomplete d orbitals either in the ground state or in the common oxidation state. So that is why it is not a transition element. It is a d block element but not a transition element. Okay, 2, everybody has given wrong answer. The correct answer is option number B. Palladium, if you see, its electronic configuration is Kr4d10. Okay, there is no s orbital here, so that is why this is an exception. Please remember, it is given in the book also, so mark this one. Okay, 2 is B. So I have only Mohammed who has given correct answer here. Okay, next question number 3. Please read the question. The electronic configuration of chromium is 3d5 4s1 instead of 3d4 4s2. It is due to the energy gap between the two sets 3d and 4s of orbitals is big enough to prevent the electron entering the 3d orbitals. The energy gap between the two sets 3d and 4s of orbitals is small enough to prevent the entering the 4s orbital. The energy gap between the two sets 3d and 4s of orbital is big enough to prevent the electron entering the 4s orbital. The energy gap between the two sets of orbitals is small enough to prevent the electron entering the 3d orbital. Options are very confusing, so please read 2 times and then answer. I'll get a bit side so that you can take 1 minute to read all the options properly and then you can answer. D is same. Okay, so stay here. First of all you should know 3d and 4s. Okay, the energy gap here is low. Okay, so first let us eliminate where they are saying that it is the energy gap is big. That is wrong here. Here it is saying big. We can eliminate this option too. Okay, now the energy gap between the two sets is small enough to prevent the electron entering the 4s orbital. So if you see, we should have 3d4 4s2, right? So exactly what happens here, one electron comes from 4s to 3d, right? So the electron is entering 3d orbital instead of staying in 4s orbital, right? So where it is entering, is it entering 4s orbital? No, it is entering 3d orbital. So that is why option number D here. Okay, D here. I hope it is correct now. Yes, 3 is D. Sangeeta is absolutely correct here. Let's move for question number 4 here. Among copper, mercury, cadmium and CN, which is or are not regarded as transition elements, not regarded. You have copper, then you have cadmium, mercury, and CN is copper sneum. Okay, copper sneum, the element name. Your mercury, cadmium, mercury, copper and CN only. So what is the correct answer here? Tell me quickly. Yes. Yes, so I am getting the correct answer. 4 is we have mercury, cadmium and CN. Okay, so you can see their electronic configuration: 4s1 3d10, 5d10 6s2, 6d10 7s2. So they have fully filled d orbital in all the cases. Okay, fully filled d orbitals are present, so that is why it is not a transition metal. Okay, so option number C is the correct answer. So Dhanva is correct and Mohammed is correct here. Let's move to question number 5. The orbitals of the transition elements that protrude to the periphery of an atom more than the other orbitals is, means which orbital is more towards the outer side. It is not closer to the nucleus, it is towards the periphery. So is it s orbital, p orbital, d orbital or f orbital? Remember, it is asking transition elements. Okay, so which one will be the correct answer? Yes, all of you is correct, it is transition element. So here is the question from Neon. Why CN? So you can see this is the configuration of CN. Okay, and you can see they have also completely filled d orbitals, right? They have completely filled d orbitals, so that is why we cannot call them as a transition element. Okay, so that is why both here we have mercury, cadmium and CN. All of them will have fully filled d orbitals. Clear? Okay, now we will move to question number 6 here. The elements having the minimum volatility among the following. Minimum volatility means you should be thinking about strongest metallic bonding. Strongest metallic bonding is present in which of the following? 6B. Yes, definitely tungsten is the correct answer. Mood has given correct answer here. So I have some, yes, no, Ramesh, it is B. Tungsten, if you see, tungsten has maximum number of unpaired electrons, and if you have seen that graph also, tungsten melting point is the highest, right? So highest melting point means it has very strong bonding, so that is why it is very less volatile. Okay, it is very difficult to boil also, so that is why it is tungsten. Yes, those who are saying B, it is correct. 7, the correct statement among the following is: metals with very high enthalpy of atomization tends to be noble in their reaction. Tends to be noble means they are inert or they are not very reactive. Next we have metals with very low enthalpy of atomization tends to be noble in their reactions. Next we have metals with very low enthalpy of ionization tend to be noble in their reactions. Metal with very high enthalpy of atomization tends to be highly reactive in their reactions. Yes. Can we have the answer here? 7. I am getting wrong answer from all of you. So students, see, when you have high enthalpy of atomization, okay, you have two atoms like this. Okay, when you have high enthalpy of atomization, very high of enthalpy of atomization, that means you need to give a very strong energy to break the bond. Okay, so that means it is very difficult for these atoms to react because you have to give a lot of energy to break them. Once you break them, then only they can react, right? So that means if they have very high enthalpy of atomization, that means they are very less reactive, okay, or they are inert, or we can say they are more towards the noble gas. So the correct answer here will be option number A, that was given correct by Ashwini. Okay, Ashwini has given the correct answer here. Let's move to the next question. Again, statement based question here. Metals of 4D and 5D series have greater enthalpies of atomization than the corresponding elements of 3D series. And you have more frequent metal-metal bonding are found in the compounds of heavy transition elements. So statement, again, 1 is correct and 2 is incorrect. Both are incorrect, both are correct. 1 is incorrect and 2 is correct. Yes, Sudhanva, can we get an answer from you? Yes. So I have got Mohammed has given a C, that is absolutely correct. Both are correct here. So remember students, as we move down the group, the enthalpy of atomization becomes much more stronger because of stronger metallic bonding. So the first statement is correct. Metals of the 4D and 5D series have greater enthalpy of atomization than the corresponding elements of the 3D series. And next one, more frequent metal-metal bonding will happen in the heavy transition metals. Okay, as we go down the group, the enthalpy of atomization will be much more stronger. Yes. Ninth one, in transition elements, a regular decrease in the atomic radii is the result of the filling of n-1 f before nd orbital, the filling of nf before n-1 d, the filling of n-1 f after nd orbital, and the filling of nf after n-1 d orbital. Again, a very good question here. So if you remember, you have n-1 f and you have nd. So always first n-1 f is filled, then n-nd is filled. Okay, so what happens? First n-1 f orbital will be filled, then nd orbital will be filled. So the answer here will be the filling of n-1 f before nd orbital. Yes, those who are saying A, yes, Neon, you are correct. F is a poor screener here. So we have option number A here. Okay. Students, please write down the answers with question number so that will be a little bit easy for understanding which question you are answering. The element with least density is, very simple question, least density. Chromium, nickel, zinc and scandium. Least density. Yes, which element is having least density? Yes, quick, very simple answer, this one. Yes, very good. Marudesh is correct here. Scandium is the correct answer, the element with the least density. So if you remember, as we move along the period, the density increases. So scandium is the least one. Yes, so Dhanva is also correct here. Ramesh is also correct here. 11th question here, exchange energy is approximately proportional to. There's a paragraph on exchange energy in the NCERT textbook. So if you haven't read, please read that. So here you have to answer what is exchange energy proportional to. Total number of possible pairs of parallel spins in the generate orbitals. Total number of possible pairs of anti-parallel spins in the degenerate orbitals. Total number of possible pairs of parallel spins in the degenerate orbitals, total number of possible pairs of parallel spins in the generate orbital. So first of all, you should be remembering two things, that is, we should have parallel spins, okay, and degenerate orbitals. Parallel spins and degenerate orbitals. So wherever anti-parallel is there, I will eliminate that option. Wherever generate orbital is there, you can eliminate generate orbital, eliminate. We have option number C here. Okay. Yes, Neon is correct here. 11th C is the correct answer. Next question number 12. The element having the stable minimum oxidation state of +1. So which element is having +1 stable oxidation state and it is stable also? Can we guess this answer? This is very simple. Yes, +1 oxidation state, 12B. Yes, copper is correct. Copper is correct here. Copper, if you see, +1 has 3D10 configuration, which is highly stable. Okay. Yes. Neon, copper disproportionates in the aqueous medium. Okay, it disproportionates in the aqueous medium. But here we have not been given whether it is aqueous medium or not. When you take copper plus in aqueous medium, it disproportionates to Cu2 plus and Cu, but only in aqueous medium. But in general, if there is no aqueous medium, that means copper 3D10 is more stable because of this D10 configuration. Okay, this reaction happens only in aqueous medium, so please keep that in mind. Okay. I hope, Neon, your doubt is clear. Please put me a thumbs up or let me know if your doubt is clear. But a very good question. Absolutely, you have understood the concepts into depth. 13th one, which of the following transition metals cannot displace hydrogen from acids? Very easy question. It cannot displace hydrogen from acids. Yes, anyone? Cannot displace hydrogen from acids. yes, again the answer here is copper. Copper cannot displace hydrogen from acids. Why? The reason is because of its positive reduction potential. Okay, so copper itself get reduced, it does not allow hydrogen to get reduced, so that is why no hydrogen gas is produced here. Yes, Sudhanva is also correct. Avi Shankar, no beta, it is not B, it is D. Okay. Next, question number 14, very easy question again. The ability of fluorine to stabilize the highest oxidation state of transition metals is due to. So we know that the transition metals and its highest oxidation state are stabilized by two elements, fluorine and oxygen. So what is the reason why fluorine can stabilize? For oxygen, the reason is it can form multiple bonds. But for fluorine, what is the reason? Low lattice energy and high bond enthalpy, high lattice energy and high bond enthalpy, high lattice energy, low bond enthalpy, low lattice energy, low bond enthalpy. Let's see who is giving the correct answer for question number 14. Yes, I can find B is the correct answer. Yes, that is from Sudhanva again. So yes, B is the correct answer because of high lattice energy and high bond enthalpy. Yes, Ramesh and Sangeeta, Neon, everybody is correct here. Let's move to 15th question here. The stability of Cu2 plus rather than Cu plus in aqueous solution is due to. So question here is saying that in aqueous medium, Cu2 plus aqueous is more stable than Cu plus aqueous. What is the reason here? Even though Cu has D10 configuration, Cu2 plus is more stable. More positive hydration enthalpy of Cu plus, more negative hydration enthalpy of Cu plus, more positive hydration enthalpy of Cu2 plus, more negative hydration enthalpy of Cu2 plus. Yes, 15th question, students, 15th question. If you are liking the session, then do let me know. If you are enjoying solving questions with me, please let me know in the comment section. Okay. Yes. 15, no Neon, you have, this is wrong here. See, Cu2 plus has more negative hydration enthalpy, more negative hydration enthalpy of Cu, not Cu plus. Cu2 plus is more stable, right? So Cu2 plus has more negative hydration enthalpy. So that is why option number D, which compensates the second ionization enthalpy of Cu. Okay, so you can see in Cu what is happening. See, Cu to Cu plus you are going, then Cu2 plus you are going. Here what happens? 3D10 configuration. 3D10 to 3D9 you are going. Okay, so here you have to give a lot of energy. Okay, that actually makes this species unstable because you have to give a lot of energy. But once you dissolve it, it releases out the hydration enthalpy is so much more negative that it compensates this highly like the ionization enthalpy, the highly positive ionization enthalpy is compensated here. Okay, so it is option number D here. 15 is option number D. Next, question number 16, the correct increasing order of oxidizing power. Here remember, oxidizing power is directly proportional to oxidation state, or I can say oxidation number. Can we think what is the answer here? Yes, 16th one, all of you please put down the question number and answer. With question number, I will read out only those students' answer who are putting with question number. Okay, if you are not putting question number, I won't read your answers. Sudhanva is saying B. Ramesh, question number, please put the question number. Marudesh, question number, yes. 16th A is correct answer. So if you see here, the oxidation state is +4, here it is +6 and here it is +7. So higher the oxidation state, more will be the oxidizing power. Next, question number 17, again we have statement based question here. Fe3 plus shows paramagnetic and magnetic moment is 5.92 bm. Fe3 plus ions have D3 configuration. Identify the correct statement. So yes, please answer me with the question number only. Okay, without question number please don't answer. Sangeeta is correct here. 17th D. Statement 1 is correct and statement 2 is incorrect. So Mohammed has given me correct answer. Neon has given me correct answer. Yes, this is correct. So if you see Fe3 plus, okay, has the configuration of D5. Okay, Fe3 plus has D5 configuration. So D5 means 5 unpaired electrons. So magnetic moment here is 5.92 bm. Okay, now next what happens? it doesn't have D3 configuration, it has D5 configuration. So statement 1 is correct, but 2 is incorrect. So D is the correct answer. So Spinners is giving so many gifts for all of us, right? So Spinner, thank you so much for all your hand wash, stickers, and I am not able to guess some of them. Okay, thank you for these stickers anyway. Let's go for question number 18 here. The element having maximum magnetic moment in its divalent ion. When it is having divalent ion, which is the highest magnetic moment. So Mohammed has already given the answer for 18th question. Mohammed, please check your answer. Sanjay, yes, I am getting Neon and Marudesh has given me correct answer. So if you see Cr, what is the electronic configuration? 3d5 4s1. Divalent ion means Cr2 plus. So that means it will have 3d4. Number of unpaired electron is 4. But if you see Mn2 plus, the unpaired electrons is 3d5. 5 unpaired electrons are there. So that is why here there will be maximum magnetic moment. Yes. Those who are saying D. See, Fe is having 3d6 4s2. Okay. Fe2 plus will have 3d6. Now how do we write 3d6? See, 3d6 is 1, 2, 3, 4, 5 and then 6. So how many unpaired electrons we have? 4. Okay, we have 4 unpaired electrons. Here we have 5 unpaired electrons. So that is why D is incorrect. Okay, B is the correct answer. Let's move to 19th question here. The transition metal A forms highest oxidation state only with oxygen, okay, which is acidic and covalent, and its divalent ion has the maximum magnetic moment. Just now we have solved this. Its oxide oxidizes iodide ion into iodate ions in the neutral medium. The metal is. Yes, absolutely correct here. Neon has given correct answer. It is manganese. You can see it is saying all the properties. So manganese has Mn2O7, right? It exhibits its highest oxidation state with oxygen. Then this compound is acidic in nature, it is covalent in nature, and its divalent ion has the maximum magnetic moment. So we have just seen Mn2 plus have 5 unpaired electrons, so it is having the maximum magnetic moment. Also MnO4, its oxide, which oxide we are talking about here? MnO4 minus, right? It oxidizes I minus to IO3 minus in the neutral medium. Okay, so we have B is the correct answer. Last question from this chapter. The basic oxide among the following is, which is the basic oxide? We have Cr, so amphoteric oxides we all remember, but basic oxides, do you remember? CrO3, Cr2O3, CrO and CrO4. Yes, basic oxide. Neon again is the correct answer here. Mohammed, no, it is not Cr2O3, it is CrO. So remember, lower oxidation states, okay, will have basic nature. Okay, higher oxidation states will have acidic nature. Clear? Next, we'll just revise what all things you should be revising from this particular chapter. See, why transition element shows catalytic property, why the color of the compound, then interstitial, okay, interstitial and complex formation. You should be remembering these answers. Preparation of KMnO4 and K2Cr2O7, very, very important. Lanthanide contraction, cause and its consequence. Magnetic moment, how to calculate. Actinoids contraction, and then why it is difficult to study actinoids. These are some important questions. Take a screenshot and then we will go to the next chapter. Okay, last chapter, that is haloalkanes and haloarenes. Let us quickly solve the question. Question number 1 here already for all of you, that yes, chlorine containing antibiotic produced by microorganisms, which is very effective for the treatment of typhoid fever. This is given in the introduction part of the chapter. So what is the answer? That is, and I have also taught you in my Sankalp classes if you have followed. So chloramphenicol is the correct answer. Already Sudhanva has given me the first correct answer here. Hello Sneha, good evening. Yes, Neon has also given the correct answer. Next question, the halogen containing following compound used as an anesthetic during the surgery? Same options you have: chlorophenicol, chloroquine, you have thyroxine and halothane, which is used as an anesthetic during the surgery. Yes, absolutely correct, Sudhanva. Very good, mind blowing, and you are fabulous today. Okay, 2D. Yes, Marudesh is also correct here. No, C is not the answer. We have halothane here. Let's move to the third question. 1,1-dichloroethane is also called as, very good question, ethylidine chloride, ethane chloride, ethylene dichloride and pyrene. 1,1-dichloroethane. You have. So just tell me whether it is a geminal dihalide or a vicinal dihalide. Gem or Vic? Comment and tell me first. Gem or Vic? Comment and tell me. Geminal dihalide or vicinal dihalide? Tell me quickly, all of you. Tell me quickly, geminal dihalides or vicinal dihalides? Yes, Sudhanva, geminal, Hacker, geminal, yes. So remember, whenever we have geminal dihalides, okay, so it is written like this: ethylidine chloride. Okay, if you have vicinal halides, then you would use the word dichloride. Okay, for geminal we use dine in the alkyl part, not in the halogen part. So here the answer will be option number A. Okay, those are given A. Yes, Marudesh, Sudhanva, Neon, and we have Ashwini. All of you have given correct answer. Let's move to the fourth question. The total number of structural isomers possible for the compound having molecular formula C5H11Br. Take your time and solve this question. It will require certain time for you to think. C5H11Br will have how many structural isomers? Very good question. Yes. How many we will get here? C5H11Br. Marudesh has told 4B. Marudesh, I'll tell you to think for some more time. Mohammed also is saying B. Neon is saying C. Vishkar is saying A. Okay, so for now, Neon is correct. Okay, so C5H11, see here. You have 5 carbons. Okay, so where all things where I can place bromine, that I'll get different compound. I can place bromine here, that will give me 1 bromopentane. There's another possibility, I can place bromine here, that will give me 2 bromopentane. Then I will have another possibility here, that will give me 3 bromopentane. Okay, so when you have 5 carbon chains, we have got 3 isomers. Now let us try with 4 carbon chains. So if I have like this, you give 1 bromine here, so what I will get compound here? I will get 1 bromo 2 methyl butane. Okay, 1 bromo 2 methyl butane. Now let me try another product. If I have this one, so this one will be 2 bromo 2 methyl butane, 2 bromo 2 methyl butane. Then I have another, I can put here also bromine, so that will give me 1 bromo 3 methyl butane. All of them are different. See, this is 1 bromo 2 methyl. Okay, I'm just writing in short. This is 2 bromo 3 methyl. Okay, 2 bromo 3 methyl. This is again 1 bromo 3 methyl. Okay, so I have got here 3 and I have got here 3. 3, 3, 6 I have got. Now if I can I plan anything else here? Can I get, yeah, I can have one more, right? You can have on the same carbon, right? We can have 2 bromo 2 methyl, 2 bromo 2 methyl. So 1, 2, 3, 4, 5, 6, 7 I have got. So with 5 carbon chain I have got, with 4 carbon I have got. Now with, let's try with 3 carbon chain. If I have this one, anywhere you put bromine, it will give you the same compound. So you will get 2,2-dimethyl and 1 bromopropane. So total I will get 8 isomers. That is option number C. Yes, those who are saying C, it is correct. So Neon and Sudhanva, both of you are correct. Let's move to the 5th question. All of you please take a screenshot of this one. This is important question. Take a screenshot and let's move to the 5th question now. Which among the following has a chiral carbon? So what do you mean by chiral carbon? A carbon which has 4 different groups attached. Okay, so Sangita, it is 8, dear. Please check it. Okay, so we have 4 different carbons, 4 different bonds are present. 2-chloropropane. If I draw 2-chloropropane, is it having 2 different groups? No, it is having methyl group on both the sides, not this one. 3-chloropentane. Okay, if I see here also ethyl group, here also ethyl group, this is also incorrect. 2-chlorobutane. Yes. If I see this one, this is chlorine, this is hydrogen, this is methyl, this is ethyl, right? So it is having 4 different groups here. So 2-chlorobutane is the correct answer. 2-chloro, 2-methyl propane. Let us check this one. I have 2-chloro, 2-methyl propane. So here also both the side I have methyl group. 3 sides actually is methyl group. So that is also incorrect. Okay. So C is the correct answer. All of you are correct here. Sudhanva, Nian, Amu and Nikita. Next, question number 6, let us see. The alkyl compound having largest CX bond. Very simple question. You need to have largest CX bond. Okay. Easy question. This is easy question. CH3Cl, CH3Br, CH3I, CH3F. Largest one. No, Marudesh, you are incorrect. This one will have smallest bond. Okay. Iodine is the biggest atom, so here we will have the largest CX bond. Yes, Avishkar is correct, Neon is correct. Let's move to the 7th question. Alkyl compound having the largest CX bond enthalpy. Largest CX bond enthalpy means very strong bond is present between C and X. What can be it, that one? CH3Cl, CH3Br, CH3I, CH3F, which is having largest CX bond. Yes, yes, Yashwanta. Just I have made 2 videos. Okay, one discussed all the questions. Another video I have told you what all things you should revise, and these questions just practice that. You will definitely get very good marks. Okay, 7D is absolutely correct. Because of small size, the bond is very strong and the bond enthalpy is very high. Next question, the alkyl compound having the least dipole moment. Least dipole moment. 7th one, Neon, Mohammed, Nikita, Sudhanva, Ammu, all of you are correct here. Next question, see the question number 8. Nikita, please answer with the question number. Okay. Yes, Neon is correct here, 8C. Okay, 8C is correct. Here you have least dipole moment. Why? Because iodine is least electronegative. Okay. No, Mohammed, it is not CH3F, it is CH3I. The best reagent used to produce pure alkyl halides from alcohols. Which is the best reagent? I am expecting everyone to give correct answer here. Yes, Sudhanva is correct, Marudesh is correct. Okay, Nikita is correct. 9C, yes. 9C, everyone here is correct. Again, Marudesh, we have Mohammed, we have Sudhanva, Avishkar, Neon, Nikita, Pavan, Amu, all of you are correct here. Great, dear. So when I use SOCl2, what happens? Can you say why it is the best method? Can you just let me know why it is the best method here? Why this SOCl2 is the best method? Please put down in the comment section. I will go to the next question. If you don't answer, I will answer. Okay. So let's, by that time, I want all of you to tell me why SOCl2 is the best method. 10th question. Aryl halides cannot be prepared from phenol because, see, I have this reaction, right? If I ROH, if I give PCl5, I will get RCl. But if the same thing you have AROH, okay, and if you use PCl5, you won't get Cl. Okay, this reaction is not possible. Now, what is the reason for that? Phenol is more reactive than aryl halide. Aryl halide is more reactive than phenol. Carbon-oxygen bond in phenol has a partial double bond character. Carbon-oxygen bond in phenol has a less bond energy. Yes. Yes, Mohammed is correct because other byproducts escape. They are in gaseous form. Yes, yes, all of you are correct here. Now, can you answer me for the 10th question? All of you are correct here. 10th question. What will be the answer for 10th question? C. Yes, absolutely correct. Here what happens? Due to resonance, we get a partial double bond character. The bond is partially a double bond, as a result of which this bond is very strong and difficult to break. So students, now we have last 10 questions. Okay, so like all of you just gear up and we will be solving the last 10 questions now. Okay, so yes, 11th question here, the reaction that produces a single haloalkane in low yield. You get a very low yield in this method. This is not a preferred method and you don't get a single haloalkane here. What is that reaction? Is it the reaction between alcohols and concentrated ZnCl2, reaction between alcohol and SOCl2, reaction between alkene and HBr in the presence of H2O2, free radical chlorination? Yes, those who are saying 11, they're absolutely correct. I have Mohammed, Sudhanva, Neon, Marudesh. Yes, so free radical halogenation gives you multiple products, and that is why that is a I can say not a preferred method. Okay, 12th question here, vicinal dihalides are obtained from the reaction of, we want vicinal dihalides. Okay, you want vicinal dihalides, so which reaction will give you that? Alkene plus HBr, alkene plus Br2, alkanes and Br2, alkanes and HCl. What will be the reaction here? Yes, Neon is correct, and Sudhanva, it is not C beta, it is B. Alkene with Br2. See, if you use alkene with Br2, what will happen? This bond will break and you will get Br and Br here. Right, so that is your option number B. Yes, Nishal, Avishkar, Nagaraj, Nikita, all of you have given correct answers. Siri, no Siri, it is not A, again it is B here. Okay, next 13th question, an example of vinyl halide is, what is vinyl halide? Vinyl halide is what? When you have an X directly attached to one sp2 hybridized carbon. So is it 1-chlorocyclohexene? So let me draw the structure. 1-chlorocyclohexene. Okay, you have 1-chlorocyclohex-2-ene, 1-chlorocyclohex-2-ene, then you have 1-chlorocyclohexane, you have 1-chlorocyclohexane and 2-chlorocyclohexane. Yes, which is a vinyl halide? 13th, I haven't got an answer for 13th yet. It is an easy question, all of you. Can you answer me? Yes, A is correct answer. See, this is sp2 hybridized carbon, right? The halogen is directly attached to sp2 hybridized carbon. Here this one is an allylic one, okay, but this is a vinylic one. So the correct answer is option number A, 1-chlorocyclohexene. Yes. Okay, Nishal, thank you so much for coming, and I hope you are doing well. And yes, thank you so much, Nishal, for remembering me. Okay, yes, 14th one, sim tribromobenzene is. So let me just tell you, sim means symmetrical. Okay, which of this here is symmetrical? Or let me just tell you the answer for this one. You have, if this one is there, okay, we call this one as sim tribromobenzene. Okay, so what is the name of this compound? 1,3,5 tribromobenzene. Okay, so those who have not seen, please correct it. 14D is the answer. Saundarya Creative has given the correct answer for this question. Okay, yes, Mohammed, Amu, Vishkar, all of you are correct. So guys, let's move to the 15th question here, an example of allyl halide. So just now we discussed what is allyl halide. So if you have like this is an allyl halide. Okay, so you have chloroethane, 3-chloro, so if structure A is there, chloroethane is there, you have 2-chloropropene, I have 2-chloropropene. Okay, next option C is 3-chloropropene. Okay, 3-chloropropene, and D is isopropyl chloride. Yes, so which is an allylic halide? Yes, C is the correct one, 3-chloropropene. All of you are correct. Okay, next 16th question, diacetone is used in Finkelstein reaction because it is a volatile solvent, it contains ketone group, NaCl and NAB are formed, is precipitated and favors the forward reaction, Ri formed is precipitated and favors the forward reaction. Yes, 16th one. Let me see who is giving correct answer. No, Mohammed Marudesh, it is wrong. Nikita is correct. Okay, the Ri which is formed, that is not precipitated. This NaCl and NaBr, which is the byproduct. If you remember, we have Rx, okay, plus NaI. Okay, so what you get here, Ri plus NaX. Okay, so we precipitate this NaX using dry acetone, not Ri. So that is why option number C here. Yes, all of you are correct. Nian, Avishkar, Ammu, Nagaraj, all of you are correct. 17th question, metallic fluorides not used in Schwarz reaction. Which metallic fluoride is not used? AgF, NaF, SbF3, Hg2F2. Yes. Which is not used in the Schwarz reaction? Very simple answer. Quick answer I am expecting. 17th A. B is the correct answer. Who has given? Nikita. Yes, Nikita, Sudhanva, Saundarya, Avishkar, Neon has given correct answer. Okay, sodium fluoride is not used. Other all metallic fluorides are used. Next, iodination of benzene are reversible. Iodination of benzene requires the presence of an oxidizing agent to oxidize the Hi formed. Identify the correct statement. Both are correct, both are incorrect. Statement 1 is correct, but statement 2 is incorrect. Statement 1 is incorrect, but statement 2 is correct. Let me see who is answering this question properly. This is a good question actually. 18th one. Let me see. Yes, Neon is writing A, Saundarya, Sudhanva is saying B. See, iodination of benzene is a reversible process. That is a correct statement here. And that is why iodination of benzene requires the presence of an oxidizing agent to oxidize the Hi formed. Okay, so we need an oxidizing agent here. And what oxidizing agent we used? Nitric acid is used to oxidize this Hi. Okay, so both the statements are correct here. Okay, 18A. 18A is the correct answer. Marudesh, Nikita, and we have Neon, Saundarya and Ammu are correct. Second last question, select the incorrect match. Schwarz reaction COF2, Finkelstein reaction NaI, Sandmeyer reaction CuCl2, Woods reaction Na dry ether. Which is the incorrect match here? Yes, quickly. Incorrect match here. Yes, 19C, 3 only. That is absolutely correct, Saundarya. Marudesh, no. See, this is correct. Schwarz reaction COF2 is correct, like metallic fluorides are used. But in Sandmeyer reaction, you have Cu2Cl2. Okay, if you see, it is written Cu2X2. Okay, so that is why this CuCl2 is incorrect. So that is option number 3 here. 19C. Yes, Neon and Ammu are correct. Last question, please see this question. A compound X with molecular formula C2H4. So we have a compound X with molecular formula C2H4 reacts with HBr. Okay, it reacts with HBr to give a compound Y. Okay, which on further reacts with NaI in dry acetone. It reacts with NaI and dry acetone. Okay, to give a compound Z. Now you have to identify what is Z here. Is it C2H5I, C2H5F, C2H5Br, C2H4IBr? Very simple question. Yes, all of you have given correct answer. Yes, so we have C2H5Br. So when you add H and Br, so this is like this, right? Yes, so when you add HBr, you will get CH2, we have H and we have Br. Okay, next, when you use NaI dry acetone, that is the Finkelstein reaction, you will get CH3, CH2I. Okay, so that is option number A. Yes, 20A is correct for everyone. All of you have given correct answer. So yes, that's the end of the session, but here something very important I'll be discussing, that is what all things you should be preparing for this chapter. Okay, please take a screenshot. SN1 and SN2 mechanism, then haloarenes, why they are less reactive than haloalkanes, that 3-marker question. Schwarz reaction, Finkelstein reaction, Woods reaction, Woods fatigue reaction, these all reactions you should be knowing. Then definitions, racemic mixture, enantiomers, stereocenters, chiral carbon, IUPAC nomenclature and definitions means these definitions, and and the isomerism part. Okay, so these all things please revise from this chapter. And that's all. And see, if you want to revise, I have these 3 videos where I have discussed complete revision. Here I have given you the most important questions, and if you have any doubt in DNF block, this is a DNF block one shot. Okay, so if you have time, just go through these videos and quickly revise. And that's all in today's class. Thank you so much, Ramesh K. We love you, ma'am. So I also love you all, and thank you so much for listening to me, and all the very best. Thank you, Sudhanva. Thank you so much. Okay, all the very best to all of you. Those who are having exam tomorrow, don't get nervous. You will definitely do good, and tomorrow do let me know how was the exam. And I wish you all the best. Be calm, read the questions properly, and then answer. Okay, and don't get nervous, don't get panic. If you are confused with certain questions, just give some time, write the extra questions at the end, and MCQ session should be attempted at the first page only. Okay, do not cut the MCQs. Whatever one time answer, whatever you think, write that one itself. Okay, thank you everyone, thank you so much. And yes, bye Vijay. Yes, so I'll be giving you the PDF of this in the WhatsApp channel, so please join the WhatsApp channel. Link is there in the description section. And have a good night, take proper rest, and all the very best to all of you.